Example 5, Chapter 13. An air conditioning unit is shown in this picture. With pressure, temperature, and relative humidity data as shown in the picture. Calculate the heat transfer per kilogram of dry air. Calculate heat transfer per kilogram of dry air. Assuming that change in kinetic and energy are negligible. Control volume we can use. Now first we choose control volume. Duct excluding cooling coil. This area. Inlet now. Exit now. Process steady state, steady delta PE, delta KE. M dot V1, M dot V for air. We don't have any condensing process. M dot A1, M dot A2. For the continuity and for the M dot for vapor, M dot V2 plus M dot L2, which exits from this point. For the continuity equation, for energy equation, or first law, Q control volume, M dot IHI, M dot EHE plus 4, which is 0. Control volume, M dot A, HA1, HV1, HA1, HL2. It comes from this relation Q dot control volume plus M dot A1 HA1 plus M dot V1 HV1, and at the exit also we have M dot A2H E2 plus m dot V2 HR and HV2. Replacing with this relation m dot V1 m dot V2 plus m dot L2. We have also m dot L2 H L2. We know that m dot V omega m dot A and also m dot V2 omega m dot A2 m dot L2 m dot V1 minus m dot V2, which is omega m dot A omega 1 minus omega 2. Replacing to this relation, we can obtain the first law equation as the calculated, and in that process we have this information: humidity, relative humidity, PV1 on PG1 PG1 is P saturate at PV1 omega 1 and PV2 P minus PV2. PV2 calculated, and just now pressure is at exit. At exit pressure. Q dot control volume on M dot A. We can bring the air information in one side or calculated together. Minus HA2 plus W1 HV1 minus W2 HV2 plus W1 minus W2 HL2. From nesting table we can extract this relation. Cp T1 minus T2 omega 1 is calculated. H1 HV1 at temperature and pressure. First should be checked it, and next if superheated with this table, extracting per kilojoule on kilogram of air mass.